Greetings, Subject Coder. I hope things are fine with you. Um, we're going to jump into a binary search tree structure, and we're going to look at the concepts initially. Um, see how this goes. All right, binary search tree. Um, Introduction here. Take a look through that. The fundamental goal and purpose of a tree, if you look through this, here's a tree of customers. All right, and you see they're sorted smaller to the left, equal or larger to the right. All right, is how we sort these. These are sorted by ID here. These here are sorted by name, but again, smaller sort-wise to the left. That's how these trees are built, binary search trees. And the whole goal of this is, here's a linear search, slow, right? Worst case, we have to search every element. If we have 1,000,000, we have to search 1,000,000. Average case, we have to search 500,000. In both cases, uh, they're um, they're linear, dependent on the size and of the list. So a BST, a binary search tree, is a much different search pattern. Here is the same data right here as this in form of a tree, whereas we searched about 15 times there to get to 63. Here we would only have to search, we know 63 is to the right, we know 63 is again to the right, we know 63 is to the left, and we find it here. So four searches as opposed to about 15. So that is the whole goal of the binary search tree. Um, and that's the reason we set it up as such. And we'll learn how to do that. We'll learn the small set of tricks that go along with the BST. So look through that, give a glance in the intro, and then tree. How do we build a tree? Again, similar to what we just kind of talked about. Uh, in this case here, 20, 10, 40, 30 is the data coming in the input data. 20 goes first, 10, the smaller, goes to the left, 40 larger, 30 smaller to the left. So it builds like that. And here's another example of how we build that tree. This is really the key player here is the node. This tree is just full of nodes. That's really what it is. It's the building block, if you will. And the node has data. That's the fundamental part of it. It has data. That might be a customer, could be employee, city, person, whatever. But it also has subnodes. The node also has a left node and a right node. Um, so this is the complete node, BST node here. It has data and it has a left and a right. And we see examples here. You can go through that. Operations. Here's just the algorithms for the basic operations of the BST. You can look through that. Traversal is very interesting. There's 3 primary types of traversal. One is where we traverse left and then we visit, then we traverse right. What that means is, keep thinking left, 50, 20, 10. Now we have nowhere to traverse left, so now we do a visit. That visit could be a print. So let's say we do we print it out there. Now we're back to here. Again, it's traverse left, then visit, traverse right. And visit in this case is a print. It could be anything. It could be a calculation too, whatever. So now we print the 20, and then we go, and here's left 30, back up to 40, and etc. And you'll look through this. This will make more sense once you look through this and play around with it. These traversals are very, very helpful. Balance. So a tree can become a linked list. In other words, it can achieve poor performance if it ends up like this, one branch or just a couple branches. We want it to be balanced. In other words, pretty close to the same depth. We may have a little tiny difference. For example, if we deleted the 10, we would have a little difference there. But we want a difference of about 1 level. We don't want this huge branch here with no other branches. We want a balanced tree. So that's and here's some algorithms for balancing. Balancing is fun. It takes tinkering. It takes your best coding and takes tinkering to get that to work. But you get a balanced tree, and that's how she'll work. Here's an example that I give, and also there's some examples here um, that are good examples on how to balance. Iterators, that's an advanced topic if you want to look at that. The design. So what do we end up with after all this discussion? The BST tree has a root, right? And which is a BST node, and it has a sort function and a search function. And those are just pretty much operation instance variables that help the tree operate, which you'll find out as you code it. Here's what a BST object diagram looks like. See if you can fill these out. You can show the answer then. All right, the pros of this tree. Compared to a hash table, it is better in a way of traversing. Hash tables don't traverse well. So if we want fast searching and ability to traverse, in other words, maybe traverse a range of data, in other words, walk a range of data, that would be a place where we'd want to use the BST. If we want pure speed, you cannot beat a hash table. So then the BST would be not as fast in that case. References, some references to more discussion on BST. So that's concepts, and that's really 60% of the battle, 80% of the battle. And if we know concepts, then we can easily code if we understand those concepts. We'll talk to you soon.